Okay, optional question, and it's not an easy question. So you're asked what the value of this is, and I'm going to say I don't know the value of it. So what I did was I looked at a subset of the problem, and I'll tell you what I'm looking at over here. I'm looking at this part here. Right, that's all I'm looking at. This thing right over here, and I realize it's nested. And the problem with nesting is you have to figure out what the nesting is. But clearly it has something to do with 1/4 and things being squared. All right. So what I'm going to do is just set up a sequence of events here. So let's start with that. Let's just start with the first event. I'm going to call it A0. What's A0? A0 is 1/4. Then I can kind of move one in. I'm going to say what A1 would be. And again, I'm going to move into this one now. What are you going to get? You would get 1/4 minus 1/4 squared. Now notice something interesting right away. I notice that this looks like 1/4 minus A0 squared. All right. Now let's do A2. Let's see what that looks like. Well, it's going to be 1/4 minus, let's write this down now. It's going to be, let's see, 1/4 minus 1/4 squared. Whole thing being squared. All right. Now, what do I notice about that? I notice again that this A2 looks like 1/4 minus this over here looks like the A1, right? I'll write that down. So it looks like A1. Again, this is A1 over here. It looks like A1 squared. So I'm starting to see something. I got a seed value here. A1 looks like this. A2 looks like this. So I think I could write down A3 now. What's A3 going to be? 1/4 minus A2 squared. And you can keep doing this over and over and over again. All right? Let's show you where this is in the K. I have the seed written down. I have this written down next. I have A2 written down next. And then I simply say, well, A3 is this thing over here. And then what I'm going to do is march along. Yada, yada, yada. Whoops. And I'm going to write down AN plus 1. What does it look like? 1/4 minus AN squared. All right, that's written over here. Now, certainly that presents a problem for me. I'm wondering, is it going to be a number? Or does the thing blow up or do something strange? All right? So what I did was I suggest that you look at Sage. And you do this. Again, what's interesting about Sage is it's able to do the computation pretty quickly. Like you type in x to be 1/4, and then you type this in over here. And let me tell you what this is doing over here. This is taking the number x, which is 1/4, right, minus the prior output, which in this case is just 1/4, and squaring it. And what's the dot n notation doing? It's going to approximate it. All right. Now, granted, your computer will approximate, not a problem. And the number that you get there, I'm not that interested in it. Maybe I could write that down for you. That'll be 1/4 minus 1/16. You get the idea. You got a number over here. What would you get over there? Let's take a look at it. You 16. Let's see, 3/16. And again, it's going to approximate it. And you do this, and you keep repeating it over and over and over again. And it's easy to do that. You just like a copy paste, copy paste, copy paste. What you start to realize is it starts to narrow down to this number over here. Right? Pretty quickly too, by the way. And it just seems to stay there. And the question is, what is that number? What is this number? Right? I don't know what that number is looking at it. I have no idea what that number is. So what I do is I go on the next step and I start to realize, and we're looking at this over here, but I'm pretty convinced that this is going to go towards some number. All right? This is the number I think it's going toward at this point. So I want to see if I can figure out what that number is, because that's not the number. That's just an approximation of the number. So what I do is I write it down. And what I'm going to say over here is, as n goes to infinity, right? What does that mean, a limit? So what I do, I take a limit of both sides. Limit of this side, limit of this side over here. Well, what I know about this thing, as I go towards infinity, that these things are not going to differ. They're going to be the same thing. All right? In other words, the limit, as n goes to infinity, of an plus 1 is still going to be the same thing as the limit as n goes to infinity of an. And I'm going to say, I still don't know what that is. I'm going to call it x. Again, this is my x now, the thing I don't know. I said it's x. What do we get? We get this equation over here. Let me write this down for you. So x equals 1/4. That's my limit, by the way. I just don't know what the number is. Minus x squared. I'd multiply both sides by 4. I'd get 4x equals 1 minus 4x squared. Oh boy, what would I do now? I'd probably use zero product rule if I could. That's going to be 4x squared plus 4x minus 1. That does not look factorable using integers. I'm going to use a quadratic formula. And you're going to get x equals, let's see, twice the coefficient on the square term. That goes on the bottom, which is 8. The opposite of the coefficient on the linear term, minus 4, plus or minus. I think you get the idea. I've been in quadratic formula for quite some time now. That's going to be 16 minus a minus 16, which is plus 16. And what do you get there? Let's be very careful. Minus 4 plus or minus the square root of 32 over 8. You get x equals minus 4 plus or minus 4 root, because 16 is in 32, by the way, 2 over 8. X equals minus 4 plus, I'm sorry, not minus, I'm going to reduce it, right? Get this out. I'm going to reduce it by a factor of 4. So minus 1 plus or minus, let's see, that would be root 2 over, I'm dividing by 4, right? 2. That's two separate numbers, by the way. I'll write them down for you. Minus 1 plus root 2 over 2, which I hope you realize is a positive number. And the other is going to be minus 1 minus root 2 over 2, which is a negative number. Now, granted, remember what we're talking about. This number here it's positive. So I'm going to throw this one out. All right? So I'm going to say my x here is going to be this number. All right? Root 2 minus 1 divided by 2, which, again, if you use a calculator, is approximately what we said it's going to be. It's going to be this guy over here. No different. What am I going to do now? I'm going to plug it in to what we want to know. All right? Now, certainly, we found this. You know what? I just noticed there's an error in the K. I have to correct it. You're not going to see that. There's an error there. Let me see. You know what? I'm sorry. There is no error there. There is an error there, but it's not that. Let me get my eraser out again. Let me erase this, see what I did wrong here. Oh, no, that's x. I'm sorry, that is x. That's x. I put out what I mean by this. Go back over here. And we said that this thing was the x in the problem, the unknown, right? Sorry about that. Then what do? Plug it in. Now we plug into the form that we're given, which is 3/2 minus 2 times that x being squared. And let's plug it in. You get 3/2 minus 2. This is the x, and we're going to square it. And let's do that now, all right? Some arithmetic over here. Let's write this down. 3/2 minus, well, the bottom is 4, and 2 times that, we're going to give you 2 here. And I got to square the square root of 2 minus 1. What would that give you? It would give you 2 plus 1 minus 2 root 2's. That would be 3/2 minus 3 minus 2 root 2 over 2. Let's see if we can do that. That's 3/2 minus 3/2 plus 2 root 2 over 2. Well, these things conveniently disappear, and you're left off with the root of 2. Thank you.